Okay, reactions of hemiacetals and acetals. Now, we'll talk about what those are as we make them, because that's what we're doing. We have an aldehyde plus an alcohol. What happens here, we can picture it as the H of the alcohol goes here, opening up that double bond, and then the rest of this hooks onto the other side, onto the carbon. So it's like an addition reaction for a very large molecule. So when we get done with that, the double bond has opened up. And then we have the hydrogen here, and then we have the O right there. So everything adds, there's no water lost or anything along that line. Everything gets added to it. Now this general form is a carbon, OH, hydrogen, then you have an O bonded to an R group, that's below here, and then we have another R group. And this is a hemiacetal. Very complex, but it's a very important structure in biochemistry. That's why we're studying it. And then if we do a ketone, you can see instead of a hydrogen here, instead we have this, like we had up here, we have an alkyl group, so we can do this with a ketone too. That's why I drew this in hastily, because I didn't have this as an example. We got a lot of reactions, but I didn't have one where we have a ketone. The hydrogen goes to this oxygen, opening up the double bond. The rest of this alkoxy group goes on to the other side. And now we have this alkyl group here, O, and if I'm off screen, I'll get back in a second. Yeah. So this is, again, we have an R group, and actually, so we have this C, we have O, H, we have OR, we have an R group here, we'll call R prime, and then below we have another R group, and we'll call it double prime. In your book they call them R, R1, R2, and R3, but just different alkyl groups, and this is still a hemiacetal because of that alcohol, or that OH group on top. Okay, now, so another one here, picture it as this whole, this hydrogen is its own part of this is like an HCl. If we're adding HCl across here, that'd be pretty easy, or two hydrogens. In a hydrogen molecule, we just open up that bond, but this hydrogen goes here. Now we have this whole group that goes and attaches to the carbon. So we draw it out, OH, and don't worry if it's a little messy, just try to make sure you get all the groups on here. That's all I'll be looking for. We have this. You can see this is still just this molecule up here without the hydrogen. Make sure I got it right. Yep. Everything looks good. Now we get this intramolecular hemiacetal. This is important because carbohydrates will loop back on themselves and form these bonds, and these types of bonds, these types of structures. So if I had covered this up, made it look like two different molecules, it'd be the same as before. But if these two functional groups are latched to the same molecule, this will come around. The hydrogen will go here, and this oxygen will be brought around, bond with this carbon, and I might have to pull back here so you can see everything, and create a ring. Now there's 1, 2, 3, 4, 5, 6, 7, 8 carbons and an oxygen that form the ring. So I drew it out earlier just to make sure I had some basic idea. So we have this, and I'm going to put a dot at each carbon because it's 9. I won't do that on the exam. I won't be that mean. But this oxygen bonds around, and here's this oxygen here. So we have this OH group, and we have the hydrogen. And then, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's the whole thing. As nasty as it is, but it loops back on itself. Now this one is a little nicer because when we loop back, 1, 2, 3, 4, 5, 6, 7, 8. It's going to be an 8-membered ring, so we can just draw it out like this. Then we have an oxygen here. That's going to be this oxygen that comes in here. This hydrogen goes over. So we have, this carbon is the same as this one. So there's an OH group here, hydrogen. You can see that it still forms a hemiacetal. Still has, and then we have this methyl group here. You can see that we have a carbon, and there's an O attached to an alkyl group. Even though it latches back around, it's still O with an R group on it. The hydrogen OH group here, and it's the same structure as the hemiacetal, regular hemiacetal, just that it is in a ring form. Okay, for this one, I think I can go back out. Now for this one, we already have part of, this is a hemiacetal already, and we can keep going with this. Now what happens here is that we have this hydrogen and this OH group go off and form water, and then this OH group latches on in its place. So, let me make sure that's what we're supposed to be doing here. And, yeah. So what we get is we draw this structure. This part, this alkoxy group, is not affected. It's not part of the process now. We have a hydrogen that we didn't show before, and then we have 2, 3, 4. So now we have that next alkoxy group that's been added on. So make sure I got everything. And then 1H. And the difference now is that we lose a water. So it's a condensation reaction. So when we have, this is our, oh, I should also say, so this is a hemiacetal. We react it with another alcohol, we create an acetal. So the general form of the acetal is that we have a carbon, a hydrogen, we have one oxygen attached to one R group, then to another R group, and then to, and I'm going to use their numbering. I used dashes before, but they have R1, let me see, R3 and R2, just to indicate that these are different alkyl groups. So now, instead of having an alkoxy group, a hydrogen, an R group, and an alcohol, we have two alkoxy groups. So we've gone about as far as we can go there. So you need to recognize the structure. We see that we don't draw the hydrogen, but we can see that we have a hydrogen, an R group, an OH group, and an alkoxy group. That makes this a hemiacetal. Or in other words, part of an acetal. We're almost there. So if we can take this OH group, this hydrogen, those go off. Oh, I'm sorry, it's not that hydrogen. It's this hydrogen. Those go off, and so it's that OH group, that hydroxy group becomes an alkoxy group. So 1, 2, 3. That hydrogen is still there, and we complete our acetal group. You might have heard it called an acetal as well. Hemiacetal, acetal, hemiacetal, or acetal, either way. And then we have, this is an acetal group. So like we often do, we'll create the structure and then we break it apart. So one of the hydrogens goes off with an alkoxy group. The other OH group, make sure I got this here. So it goes off, and then we'll take this group, it's a small group that attaches to the OH group, and then it leaves behind one oxygen that becomes double bonded to the carbon. So let me just draw it out first here. We have 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And this oxygen, we'll say, gets left behind and becomes the ketone. And you might say, well, what if this one's left behind? Same thing happens. So, and then, but these two groups are pulled away, or these two alkyl groups, so we have two methanols. Basically we're pulling this oxygen and its alkyl group off, making it an alcohol. They happen to be the same one. And then what gets left behind is the ketone. So let's take a look at it from that point of view. You see this mess, and like, oh gosh, what's going to happen here? Well, we're going to have to remove this and remove this, and those become alcohols. So we have 1, 2, so this is going to be 1, 2. So this guy goes off, and this is an ethanol, and then this is a propanol. Now, so we've clipped these off, and we've added water to one, H to one, and then OH to the other, and that leaves one oxygen behind. So we draw the structure. Let me draw it as just exactly the way it's shown. And then that last oxygen becomes a ketone. So it takes a little bit of work to get used to it, but it's really a set procedure. So I've given you a couple to do of each type. There's some in the book. If you have any questions, let me know.